Traditionally, multimodal models are created by stitching together text-only, vision-only, and audio-only models in a suboptimal way at a secondary stage. Gemini is the multimodal from the ground up, so it can seamlessly have a conversation across modalities and give you the best possible response.
Gemini is our largest and most capable model. It means that Gemini can understand the world around us in the way that we do and absorb any type of input and output. So not just text like most models, but also code, audio, image, and video.
Hey guys, welcome back to my channel. Today I'm going to be talking about a new model released by Google called Google Gemini. It was released on December 6, 2023. It's one of the large language models, one of the cutting edge family of multimodal artificial intelligence large language models developed by Google's DeepMind. It significantly surpasses its predecessor model that we all were talking about when it was released, called PaLM 2. So this is much better than the PaLM 2 model. This model, we will be doing a coding session for the model at the end of the or in the second half of the video. We will be using a Google Colab notebook, using the Gemini API to achieve some of the tasks for text conversations as well as image conversations. So we will be doing that. So watch it till the end. And in terms of the model, so Gemini is distinguished by its multimodal capabilities, which means it can process and understand a variety of data types, including languages, audio, code, and video. This allows us to perform tasks such as task summarization, task generation, task translation, image understanding, audio processing, video understanding, and multimodal reasoning. Gemini can understand and generate text, parse complex visuals, and recognize speeches in over 100 languages. To be honest, I am learning my Korean through Gemini, and process video clips or descriptions, answers to and questions to answer. Gemini model consists of 3 sizes. It comes in Gemini Ultra, Gemini Pro, Gemini Nano. We'll be diving deeper into those. Gemini's architecture supports direct processing of text, images, audio waveforms, and video waveforms, enabling it to handle tasks across different modalities. So one of the video that previously I did was on multimodal. So if you want to learn about multimodal and how it works, you can check out the video. I was using a medical imaging example where we are using medical imaging as well as some textual data to build a multimodal algorithm. So the link is in the description, or you can just go in my channel to check it out. Gemini's training involves diverse multimodal and multilingual datasets, optimize it for a broad range of application. Additionally, Google has emphasized responsible development practices for Gemini, including extensive evaluation to mitigate risks such as bias and potential harm. And I've actually seen the API. It basically talks about all these. So it's really nice. So yeah, I'm quite excited to do a quick test on that with the Colab notebook. So we will get started. But before we dive into the Colab notebook, I think let's just hear from Google what exactly Gemini is and how does it work. Before we look at the coding section of Gemini, let's try to understand how Gemini works, or what kind of model does it use in the background. So this is a tag report from Google DeepMind. Gemini, a family of highly capable multimodal. You can download this tag report from the Google DeepMind page, or you can download it from the link in the description. Let's jump back into the model architecture section if they have. Okay, so it's right here. Right? So model architecture. So Gemini models are built on top of transformer decoders. So to be honest, this is no surprise to me. I could have easily guessed it. So transformer models has been the backbone of all the large language model development that are happening. ChatGPT, GPT4, Llama, and all those models, they actually use transformer model in the background. So this is transformer model is a very interesting topic. We have one video on it, so you can check it in the link. Check the link in the description. Obviously, they cannot use the transformer model directly. They must have done some optimization, especially for the Ultra model, because Ultra is huge and it's going to take a long time a lot of challenges will be there if you train the model for Ultra model size. So it seems like they did some model optimizations to enable stable training at scale and optimize Google tensor processing units. They are trained to support 32,000 context lengths, employing an efficient attention mechanism. That is a multi-query attention mechanism. So let's say we have been given the sentence, a group of trees, right? So this sentence could be broken down into tokens. So there are here A represent a token 1, group represent a token 2, of represent a token 3, and so on. So this is your tokens. From the tokens, these are converted into vectors, which are just numerical arrays of the word, right? And this is v1, v2, v3, v4. So these are generated. Now here, this v1 could represent a group of trees, could represent here with something other than forest, right? It could be referring here. This specific word could be referring to, let's say, crowd, right? So how can we link this sentence to the right sentence that we need? So a group of trees are forest. So like, how can we add some context to it to make it more context aware, right? Make it more contextual. So that's where this attention mechanism comes into play. So if you look at the right side on the screen, there is this image. So here you can see that this attention mechanism can be expanded further. So let's say if this word we are talking about, like crowd to forest, right? We want a context here from crowd to forest. So you can see that these are the 4 vectors I have. So generally what happens in the attention mechanism is it's going to be a dot product. So it's going to take these vectors as input, we'll do the dot product and generate these metrics. Then this is normalized because we want to have some kind of a normalized output. So we add some kind of a weight here. Then it becomes like weighted values. I'm not diving into the mathematics of it. I will keep a separate video for that. And then it generates us like all these are then combined together. So it's so if you like to relate it to a database, this becomes your key. This is what you are querying by, and then this is the value or the output that is generated. So like v1, v2, v3, v4 are your keys, and these are the queries. So if you run these queries in parallel, then it is called a multi-query attention mechanism. Multi-query attention is a variable of the multi-head attention mechanism. Particularly in multi-query attention, while the number of heads for queries remains the same, there is only one head for both key and value. This means that all the queries share the same set of keys and values. Advantage of multi-query attention is that it can be more memory efficient and have lower computational complexity compared to multi-head attention. And that's the main reason why they are being used in TPUs. The problem with like having a language model which is of the size of ultra model that they have, scaling that model will be very, very hard because the mean time between failures will be very, very low, each consisting of 4096 chips. And they are connected. So they all use this specific technique in the Gemini model. So here's the example. So you have these input sequences that can be in the form of text, that can be in the form of audio, video, image, and then they are converted into a vector, and then they're fed to the transformer, which is the self-attention part of it, attenuation part of it, and then it generates an image decoder and a text decoder. So this is the training infrastructure that we talked about. Gemini models using a TPU v5 and TPU4, and are deployed in superpods, each connected to a dedicated optional switch. So of course Google has all the forces it needs for minimizing the training time. So they exploit model parallelism within superpods and data parallelism across superpods. You can take a look at one of our video which talks about what data parallelism and model parallelism means. They use a single controller programming model of ZEX. I'm not sure if you guys are aware of ZEX, but it's a high performance computation library that offers an API for numerical computing based on NumPy syntax. But this extends powerful features for automated differentiation and GPU acceleration. So it allows a single Python process to orchestrate the entire training and dramatically simplifying the development. In terms of the dataset, training dataset, Gemini models are trained on a dataset that is both multilingual and multimodal. The training data consists of data from web documents, books, and code, include images, audio, and video. So I'm pretty sure that Google used all the data that they collect. They are using sentence piece tokenizer. So I'm not sure if you are aware of the sentence piece tokenizer. Sentence piece tokenizer is a Python library and is a set of tools designed for text tokenization. So I think that covers the model and data section of Gemini from the tech report. I think I think we are in a good shape now to start playing around with the Gemini API and see how it works. So I'm gonna be using a Colab notebook. So you can get it from colab.research.com, and you can also find the link of the notebook in the description. So if you want to see it for a later time, let me know. Also, let me know in comments if you have any questions about any aspect of the model. Happy to answer that. Okay, let's get started with the code.
To get kickstarted, you install the Vertex AI SDK, Google Cloud AI platform. You download everything that you need. One key component is that you need to restart your current runtime to basically get all of the previous package updates and library updates within the kernel available. If you were running this notebook within Google Colab, you probably have to run authentication and then authentication against your GCP or Google Cloud, your Google Cloud platform account. And after that, it's pretty straightforward. Number one, import your libraries. You can include the generation config, generative model, harm category, harm block, threshold, image, and part. This is what we're going to be using. These last two we're going to be using for the multimodality use cases that we're going to be covering. And these previous ones we're going to be using for the text use cases that we're going to be covering as well. The generation config is a very, very useful method that you're going to be able to call upon when you're basically running your models. Obviously, because we don't know where the demo gods are favoring today or who they're favoring today. I actually ran this previously. I will run some of these live in a moment, but you can see loading the model is pretty straightforward. Model equals generative model Gemini Pro is the one that we're basically using, right, in English. If I then prompt it to prompt or translate the output into Spanish, you can see it's going to provide the output in English, right? Colombia, land of enchantment, oh Colombia, land of enchantment, etc., etc. And then it'll take into account the second part of the instruction, translate the output into Spanish, and it will actually provide a response in the translation, right? Colombia, tierra de encanto, or Colombia, tierra de encanto, and you'll have basically the previous English prompt translated into Spanish. So this is a small showcase of Gemini's power, multitasking, where you can prompt it for a poem for Colombia, but then you can actually ask it to translate it into Spanish afterwards, and you get both responses in line. The next one is we prompt them all to basically create a numbered list of 10 places. Every item basically within the list should be a trend place in 2023, and we asked it to include the city and country for each place, right? So these are basically the ones that we're focusing on.
That's all from our side. Hope you liked the video. If you have any questions about Gemini, feel free to write in the comments. And do like and subscribe if you haven't already. And yeah, I will see you in the next video.
The next feature that I wanted to share with all of you is the safety ratings. So I won't deep dive into the safety ratings too much, but you can see that we're basically leveraging the same responses from them all, right? We're including the nice prompt that we basically used previously, the generation config, and we've set the true flag, the streaming flag to true. And then what you're seeing here is the feature, the safety feature, is actually taking each of the lines of text and categorizing or providing safety ratings for each of these. So around harm, is it low, high, or is it negligible, right? Around the hate speech, is it low, high, or negligible? Hate speech, sexually explicit, and dangerous content, we're getting negligible, right? So the safety ratings are basically being applied. And from here on, you can see that every single phrase is basically going through that safety rating. So you can, if needed, block some of those outputs. So some of the core capabilities that we've seen here are mainly around, the multimodality that Gemini Pro can actually bring to the table. So let's deep dive a little bit more onto how Gemini Pro Vision can, provide value to some of your use cases. So the first cells that we cover is we build a series of functions and methods to actually, handle the images and how they're displayed, get image bytes from URLs, basically the size of the images from a specific URL, loading the image from your URL, or getting the URL from Google Cloud Storage. And then the last one, printing the multimodal prompt as well, right? So the first one, very basic prompt. Again, let's start easy and then start deep diving into it. This is an image that I basically brought in from the web, and I called load from file. And my prompt is basically describe this image in Spanish. This is very important because as you can see previously, I've been prompting in English. And now what I'm prompting them all to do is actually to respond in Spanish and then translate it into English. And you can see, I'm also asking it if share the name of the place, trying to ask it to be very, very specific, very concise, so there's no hallucination involved. And when you see this picture, right, you can see the prompt below. The function was basically configured so you could see both. And then the response in Spanish, pretty straightforward. I won't go into it, but you can see in English, right, it shows a beautiful beach in Colombia. The water's crystal clear, turquoise blue. It's great on the description, right? Green mountain in the background. Some people may be sunbathing. It picked up on the folks there. But the core, I won't say shock, but very interesting piece is it called out Playa Blanca, located in Tayrona National Park. For those of you who haven't been in the in the region, there are multiple Playa Blanca beaches that are located in different parks. So it actually managed to pick up the specific beach, and I'm guessing it's because of the small huddle that you're seeing there, and it actually outputted the correct and very precise location of the image. All right.
That's all from our side. Hope you liked the video. If you have any questions about Gemini, feel free to write in the comments. And do like and subscribe if you haven't already. And yeah, I will see you in the next video.